Hello, let's solve practice set 3.2. Question first. Two circles having radii 3.5 cm and 4.8 cm touch each other internally. Find the distance between their centers. Okay. We learned if two circles touch each other internally, then distance between their centers is equals difference of their radii. Okay. Using this property, we are going to solve this question. Question first. Solution. We have distance between centers of circles touching internally is equals difference between their radii, and therefore distance between their centers is equals, as radii of those circles are 3.5 centimeter and 4.8 centimeter. 4.8 is greater than 3.5. That's why we are going to write here 4.8 minus 3.5 equals 8 minus 5 gives us 3. Decimal below decimal, 4 minus 3 gives us 1.3 centimeter. And therefore, distance between their centers is equals 1.3 centimeter. Let's see question second. Two circles of radii 5.5 centimeter and 4.2 centimeter touch each other externally. Find distance between their centers. Yes, it is exactly like first question, but the difference is in this case circles touch each other externally. Here was a case of circle touching internally. Okay. And now here is a case of circles touching external. Question second, solution. Okay, we have distance between centers of circles touching each other externally equals sum of their radii. Okay, as we know that their point of contact lies on a line passing through their centers. Okay, here in this case R1 plus R2. Radii of circles are 5.5 centimeter and 4.2 centimeter. That's why, therefore, distance between their centers is equals R1 plus R2, that is 5.5 plus 4.2. 5.5 plus 4.2 equals 5 plus 2 gives us 7. Decimal below decimal, 5 plus 4 gives us 9. 9.7 centimeter. Okay. Question third. If radii of two circles are 4 cm and 2.8 cm, draw a figure of these circles touching each other externally and internally. Okay. Question third. Solution. Okay. Now first of all, let's draw analytical figure. Circles of radii 4 cm and 2.8 cm touch each other in first case externally and in second case internally. Okay. A case of externally touching circles like this, and a case of internally touching circles will be like this. Radii of these circles will be 4 cm and 2.8 cm. 4 cm, 2.8 cm. Let O and P be the centers of these circles which touch each other externally at point T, as well as these are the circles with centers O and P touching each other internally at point T. In this case also, distance between, here you may note O dash P dash T in a case of internally touching circles, and in a case of externally touching circles, O dash T dash P. OT is 4 cm and PT should be 2.8 cm. Okay. These are analytical figures of externally touching circles and internally touching circles. Analytical figure of externally touching circles. Analytical figure of internally touching circles. Now, using these analytical figures with correct actual measures, you can draw final diagram. Question 4th. In figure, circles with centers P and Q touch each other at R. A line passing through R meets the circles at A and B respectively. Prove that saying AP parallel seg BQ. Triangle APR similar triangle RQB. Then find angle RQB. Angle RQB. If angle PAR equals 35 degree. Now let's prove. Proof. From figure PA equals PR. Okay, PA equals PR. Since radii of same circle, and therefore angle PAR equals angle PRA. Let's call it as equation 1. Since angles opposite to congruent sides, angles opposite to congruent sides. Okay. Similarly, we may mention QB equals QR. Similarly, QB equals QR. Since radii of same circle, and therefore angle QBR equals angle QRB. Let's call it as equation second. Since angles opposite to congruent sides. Okay, angle opposite to congruent sides. But here you may note angle PRA and angle QRB. Okay, it is a pair of vertically opposite angles. But angle PRA equals angle QRB. Let's call it as equation third. Since vertically opposite angles V dot O dot A. Okay, it is an abbreviation of vertically opposite angles. And as angle PAR equals angle PRA, you may mention these two angles will be congruent. And again, as these two angles are congruent, and therefore from 1 to 3, therefore from 1, 2 and 3, we may declare angle PAR is congruent with angle QBR. But here you may note angle PAR and angle QBR. It is a pair of alternate angles. Okay, it is a pair of alternate angles. Okay, and if alternate angles are congruent, then we know that lines are parallel. Okay, therefore seg AP is parallel to seg BQ. Let's call it as equation 4. By alternate angles test. By alternate angles test. Okay. Now we are interested to prove triangle APR similar triangle RQB. Okay. APR similar triangle RQB. Now, in a triangle APR and a triangle RQB, angle PAR congruent angle QRB. Okay. Then angle PRA is congruent with angle QBR. Angle QBR. Okay. Common curly for these two equations from 1, 2 and 3. Okay. And therefore triangle APR is similar with triangle RQB by AA test. And if two triangles are similar, then their corresponding elements are congruent. Okay, let's declare here this pair of corresponding angles congruent with each other. Okay, and therefore angle APR is congruent with angle RQB. Okay, angle RQB. Equation fifth. Since CAES2. Okay, corresponding angles of similar triangles. Now, as he provided here, what if angle PAR equals 35 degree, then find angle RQB. Now, as angle PAR equals 35 degree, since it is given, okay, and therefore we may mention angle PAR equals angle PRA equals angle QRB equals angle QBR, angle QBR equals 35 degree. Means each of these four angles will have measured 35 degree. Okay, 35 degree, 35 degree, 35 degree, 35 degree. Okay, now in a triangle RQB or QRB, in triangle RQB, angle RQB plus angle QRB plus angle QBR equals 180 degree. Since angle sum property of triangle, what is angle sum property of triangle? Sum of the measures of angles of triangle is 180 degree. Okay, and therefore angle RQB, we don't know measure of angle RQB, plus angle QRB plus angle QBR, each of measure 35 degree, 35 degree, that equals 180 degree, and therefore angle RQB equals 180 degree minus 35 degree plus 35 degree gives us 70 degree, and LHS it becomes minus at RHS as 70 degree, minus 70 degree, and therefore angle RQB equals 0 minus 0 gives us 0, 8 minus 7 gives us 1, 1 minus 0 gives us 1, and therefore angle RQB equals 110 degree. Let's call it as equation 6th. Let's see question 5th. In figure, circles with centers A and B touch each other at E. Line L is their common tangent. Line L is common tangent which touches the circles at C and D respectively. Find the length of seg CD. Find the length of seg CD. Okay, if the radii of circles are 4 cm and 6 cm, means in this case you may note A should be 4 cm and B should be 6 cm. Okay. Now let's draw seg AC, seg BD. By tangent theorem, angle ACD will have measure 90 degrees. Similarly, angle BDC will have measure 90 degrees. Okay. We are interested to find CD. Circles touch each other externally with centers A and B at point E, and therefore by theorem of touching circles we have A dash, A dash, B, and therefore AB will be AE plus BE. Since A dash, B, 4 plus 6 gives us 10 centimeter. We have length of AB, we do not have length of CD. Okay, for that we need a construction. Draw seg AF perpendicular BD. Okay, now here you may note, in quadrilateral ACDF, angle ACD equals 90 degree, angle CDF equals 90 degree, angle DFA equals 90 degree, and therefore angle CAF must have measured 90 degree. Okay, and therefore quadrilateral CDFA is a rectangle, and we know that opposite sides of a rectangle are congruent, isn't? Opposite sides of a rectangle are congruent. Means what will be the length of AF? That will be the length of CD. But we don't know AF. We can find AF using Pythagoras theorem applied to triangle AFB. In a case of AFB, we have length of AB as 10 cm, but we don't know length of FB. We can find length of FB. How? Let's see. AC equals AE equals 4 cm, since these are the radii of same circle. Similarly, BE equals BD equals 6 cm. Again, AC equals FD, since these are opposite sides of a rectangle. And therefore, as AC is 4, FD will be 4 cm. But here B dash F dash D, therefore BF equals BD minus FD, means 6 minus 4. Okay, and that gives us 2 cm length of BF. And now we have AB, we have BF. By using Pythagoras theorem, we can find AF. And what is the length of AF? That will be the length of CD. We are going to follow all these steps. Okay, let's start a solution. Draw seg AC, yes, seg BD, and seg AF perpendicular to seg BD, such that B dash F dash D. Okay, B dash F dash D. Now from figure AC equals AE, AC equals AE equals 4 cm, since radii of same circle. Okay, similarly BD equals BE equals 6 cm, since radii of same circle. Though reason is the same, but circles are different. That's why we mentioned these two things separately. Okay, A dash B, A dash B, by theorem of touching circles. Yes, theorem of touching circles tells us that common point of contact of touching circles lies on a line passing through their centers, and in a case of externally touching circles, that point is in between centers of those circles. That's why A dash B, and therefore AB equals AE plus EB equals 4 plus 6 equals 10 centimeter. Okay. Now in quadrilateral ACDF, angle ACD equals 90 degree by tangent theorem Okay, angle CDB or angle CDF, angle CDF equals 90 degree. Since angle CDB equals 90 degree, since tangent theorem, okay, tangent theorem, and angle DFA, angle DFA equals 90 degree, since seg AF perpendicular to seg BD. Okay, seg AF perpendicular to seg BD, and therefore angle CAF, angle CAF equals 90 degree, since remaining angle of quadrilateral, remaining angle of quadrilateral, okay, quadrilateral, and therefore quadrilateral ACDF is a rectangle, and therefore AC equals FD, AC equals FD equals 4 centimeter, CD equals AF, common कर ली, since opposite sides of a rectangle. Okay, now BD equals BF plus FD, BF plus FD, since B dash F dash D, and therefore 6 equals BF plus 4, and therefore BF equals 6 minus 4 equal to 2 centimeter. Now in triangle AFB, now in a triangle AFB, angle AFB equals 90 degree, and therefore AB square equals AF square plus FB square by Pythagoras theorem, and therefore 10 square, because already we have length of AB as 10 centimeter, 10 square equals AF. We don't know what is the length of AF, that's why F square as it is FB, FB means BF, which is 2 square, and therefore AF square equals 100 minus 4 equals 96, and that equals 16 6 are 96, and therefore AF equals root of 16 into 6 equals 4 root 6 centimeter, and therefore already we have CD equals AF, therefore CD equals AF equals 4 root 6 centimeter. This is an answer for a given question. Length of CD equals 4 root 6 centimeter. Thank you.